Welcome back to another episode of Data Science at Home podcast. I'm Francesco, podcasting from the office of Amethix Technologies based in Brussels City, Belgium. Today I want to speak about generative AI, but from the economic aspect of generative AI, in particular summarizing kind of a very interesting report about generative AI. This report has been provided by Goldman Sachs, so it seems to be a very well-balanced report, in my opinion. It goes under the title of Gen AI, Too Much Spend, Too Little Benefit. So very provocative title, of course, to indicate that probably it's time that we start reflecting on the, let's say, issues and the economic aspects of generative AI. As always, there are two different schools of thought. There is obviously the positive ones, like those who totally believe that the trend is gonna bring a lot of good stuff when it comes to US productivity, for example, or GDP growth. These are usually the two parameters that are considered in pretty much any new technology or new trend in business, in finance, technology, all the aspects of society. Productivity and, of course, GDP growth are the two parameters. I'm not a big fan of GDP growth because that doesn't include a lot of, let's say, quality of life, for example. So it's a merely economic parameter. But of course, this is what analysts usually provide. So these are the metrics that we have to frame, all the aspects of society, in particular the technological ones. Then, of course, there are those who say, everything is going to be great, and those other ones who say, I'm not 100% sure. And I'm trying to analyze a bit both. Analysis is a big word probably, but it's like reporting what is in the report. And also give you my personal opinion about all this. If as a follower, listener of this show, you might know that we hate hype. We have been doing our best in the years to, speak about new technologies and in particular about artificial intelligence in the most non-hyped way. And we are going to continue to do so because indeed hypes are good for marketeers and not for those who operate in these domains and in these fields. Also because, hypes are, they initiate some so-called bubbles that at some point burst, and we don't want that. We already had AI into different winters in the history of AI and in the history of technology. And of course, there are all the requirements for a next winter to happen, not immediately. The bubble still has to burst, in my opinion, but it will, especially if we continue, believing in the Elon Musks and the Sam Altmans of the world. That, in my opinion, have been doing, pretty bad with respect to artificial intelligence, and especially to those who operate like researchers, professors, and practitioners who are operating in the field and actually building the things, while the others are, in my opinion, pumping them up and putting words in the mouth of people about the capabilities that, in personal opinion, are very hard to believe. Now, as a matter of fact, there is only a quarter. It has been estimated that only a quarter, 25%, 1 out of 4 AI-exposed tasks that will be cost-effective in the next 10 years, right? With an impact of less than 5% of the tasks that we are currently seeing AI in action. This is not so much. If you think, it's actually very, very little. And this is kind of the negative for some, but in my opinion, the most realistic observation and analysis of artificial intelligence, and in particular, generative artificial intelligence. So this type of AI, Gen AI, the AI that we are speaking about in the last year and a half, GPT family of models, all that stuff, this is where indeed we are having big public engaged and majority of the investors engaged whenever we speak about artificial intelligence. But artificial intelligence, we have said this a number of times on this show, is not generative AI. That's just one of the many technologies that contributes to the big world and the big field of artificial intelligence, but it's not the only one. It will never be the only one. Same goes for artificial general intelligence. It's not going to be the only one technology, deep learning in particular, that will give you artificial general intelligence eventually. It's not 100% sure. I don't actually believe that's going to happen. But the reasoning tasks that some people believe that this type of artificial intelligence will actually deal and solve is not going to happen, right? I'm sorry to disappoint you, but yeah, this is the word of a technical person who's operating in the field for more than 20 years. No bragging, of course. I'm trying to show the most realistic aspects of this technology, which is an amazing technology. I personally believe in this technology, but not for the tasks and the types of problems that some people are actually, marketizing it. Now, there are some tasks, and in particular the tasks that require interaction with the world, for which this type of generative AI will not help, and we don't need to wait 10 years to understand that, right? Think about transportation, manufacturing, mining. These are all, and many others, of course. These are all tasks for which you need a very strong interaction with the world. There was a very interesting advertisement on the internet, but also I've seen it in the streets. I'm not gonna make names, but it's like it was a construction. It's a builder, right, operating in construction, and of course they have these huge panels, outdoor advertisement in which they say, ChatGPT will not solve this. Will not build the buildings that we build. It's not gonna build your villa or your apartment, right? And that's, it's a very provocative marketing, which is usually the most effective one, but it's true. Like all those tasks that demand interaction with the world, generative AI will not actually perform there. How? You need robotics, you need robots that can interact with the world, can manipulate the world and interact with it. And we are very far from there. So think about the tasks that usually use your GPT instance or ChatGPT or Bard or Gemini or whatever. There are so many, I keep forgetting now. But if you think about how you use these things, it's for really minor tasks. The most performant ones, and actually the very decent ones, are in marketing and advertisement. In real estate, for example, in which you generate this very, very nice and really ready to go messages or advertisement posts, etc., that are very good, very well written. But that's pretty much it, right? You can engage some chats, you can do some search engine, if I personally don't recommend that, but these are the tasks that you usually deal with. Now, are these fundamental tasks? No. They are important for our daily life? Yes, maybe, but we can definitely survive without. So what I'm trying to say is that this is not the so-called law of nature tasks for which, wow, if we don't have generative AI, we are screwed. No, these are tasks that, it's good to have, but it's not fundamental for society. And so the impacts that a potential artificial intelligence dealing with this type of tasks will have is minimal. And we have seen already technologies, on the cusp and then immediately falling when, people starting realizing like maybe there was an overshooting there, which is, for example, VR, virtual reality, metaverse, blockchain, and nothing, of course, there are all the requirements for generative AI to be the fourth in the list. So I've even heard of companies trying to, I don't know, for whatever mad reason, to combine VR with metaverse, blockchain, and AI, and kind of promising a product that could actually deal with, build some whatever magical tool with a combination of these four technologies. And I truly don't understand how that would be possible. And what would this task be, right? Because it's all a matter of, it's not about the technology, it's about what does it solve. Now, if we look at the costs of this type of technology, it's expected to hit the $1 trillion in the next years. So this means that the world, governments, institutions, big corporations have to prepare to spend this amount of money to build a technology that, guess what? It has to solve a $1 trillion problem. So I really dare asking out there, what is the $1 trillion problem that generative AI is going to solve? I don't think we have a $1 trillion problem. And also, I don't think that this technology can solve, if we ever had that type of problem, which is, by the way, reasoning, for example, replicating humans' most valuable capabilities, which is indeed reasoning. This technology is not able to do that, and will not be able to do so with the current network topologies or the current technology that we know, right? We have seen this, we have said this a number of times on this show, in many other episodes dedicated to artificial intelligence, and GPT in particular is like guessing, or statistically guessing the next word that comes in given a particular context, which is exactly what happens when you type your text in GPT and you ask GPT to generate. That's a statistical generation, right? We all agree on that, right? There's no magic, no God, no religion. This is what it does. And the technical people, professors, researchers, students, practitioners, have already told you a number of times, that's it. Like, reasoning is another thing, it's another story. It's not something that is achievable by predicting the next word given a context of words. You like it or not, that's not gonna happen. Now, there are many who claim, and even interviewing some people who are kind of defensive with respect to this type of technology, say, hey, look, I think that for whatever reason, they have reasons to believe what they believe, that if you throw more data and more compute to the problem, at some point we're gonna solve the $1 trillion problem that we want to solve, that we expect these models to solve, to make them, to justify the costs. And that's not such a problem. Like, this is an open world problem that is human reasoning. Human reasoning is not the type of problem for which you throw more data and more compute power, which also means bigger models, and you solve it, right? So I hardly discourage people engaging in these kind of conversations, and I've already been there. That's why I decided to have this episode, an episode about exactly this, very point, because it does make sense. There are some other folks who told me, yeah, but it will double capabilities. And even there, it's like, what does it mean? Doubling the capabilities for something that for probably you need 1000x or 1,000,000x. So having your miserable 2x, okay, it's good, but for that type of problem is absolutely nothing. So there are some problems in mathematics that are, computational complexity, and complexity is a field, a very fascinating one, by the way, that tells you how difficult a problem is, or a family of problem is, by, in a mathematical way, in a formal way. And so computational complexity is the branch of mathematics for which, applied to algorithms and computers, for which you can describe the complexity of some problems in a formal way as well. And now there are some problems that are exponentially complex, which means that they become, astronomical numbers in terms of combinations and things. And of course, the purists, the formal people will hate me when I say this, but this is not an academic definition of complexity, of course. It's just to make you understand, like, reasoning is an extremely complex task, more than exponential. If you come with a solution that does 2x or 3x or 4x, the exponent of the complexity will dominate all the time. So even if you come with 100x, the exponent of the problem and the exponential nature of the problem will not help you there. So when they say, I will double capabilities if I have a massive NVIDIA that burns 1,000 megawatt with GPUs, that's not gonna help for the type of problem that you're going to solve, which is reasoning, which is the $1 trillion problem that we definitely want these models to deal with, at least. So this is the type of argument that people have. Now, these models cost a lot of money, and we have seen this already. If you look at ChatGPT, for example, which is definitely the most used one, you know how much that costs per day? Can cost up to $700,000 per day. So this means that just to operate a model like that, you need infrastructure, you need data, you need electricity, you need research, you need regulations. When there are violations of things, we have seen that already a number of times. Images that get copied and generated, and authors that come back and say, hey, there was a copyright on that thing, and it really looks like my painting 3 years ago. So these are all costs for a model of that caliber, and it can get to 700,000 every single day. 700,000, 1.4 million, 2.1 million, and so on every day. Now, of course, there is a lot of room for improvement, which means that I'm waiting for, in a 10-year horizon, I can have better GPU, NVIDIA will come with better GPUs, with less power consumption, for example, for the same amount of teraflops, I will spend less in electricity. Yes, that could happen. It's not guaranteed it will happen, but it could happen. Now, this means that I will, let's say, improve the costs of a model as I know it today. So the GPT family of models that we are spending, let's say, $700,000 per day, in 5 years, you will spend probably $200,000 per day, right? And that's good. The problem is that the complexity of the model is also increasing in the years, because the GPT model that we expect to use in 5 years, we expect that it's going to do a lot better things and more things than what it does now. So the complexity will also shift together with the improvement the hardware improvement that you might have. And that's a problem. So all those who claim this, doubling the capabilities, increasing efficiency and all that stuff, they almost always forget or don't mention the fact that, hey, the complexity of these models also is expected to increase, because indeed in 5-10 years I want to have more capabilities for the same model. But they always forget that part, so they always mention, and they only mention how much they're gonna save if technology improves. Another argument is, again, still about technology improvement, which is true. Historically, it is true. It happens that when you see a new chip or a new piece for automotive, for example, a new computer, computers improve with the years, new materials, better software solutions. So of course there is the natural, evolution of things that improve. But many are pushing on that argument, mentioning the internet. They say, hey, when the internet came out, like in the beginning of the 90s, it took some time. No, that's another misleading argument that I saw and I heard of. That's not the case. Like, internet was ready since day one. Like, back in the 90s, you had a phone device, a modem, and you could connect overnight and enjoy the internet. We didn't have to wait 10 years to enjoy the internet, right? It was a technology that was immediately available with all the benefits that it had, immediately, instantly. And that's why, we had the dot-com bubble almost immediately. So I think it's a very misleading comparison when we try to compare this type of AI technology with the internet of the 90s. Very different things. Internet didn't have any environmental impact, except for the fact that you had to build more servers and power those servers. This is another level. Like, this is a model that requires, doesn't scale. From an engineering perspective, it cannot scale. So that's the biggest difference. And also, again, throwing more data to this problem, what does it actually mean? There is, many people are not considering that the data that we will find in 10 years, even much less actually, we're already measuring so-called statistical shifts, which means that the data that we find is more and more polluted and contaminated by generated data. And many times in several domains, it's very difficult to distinguish between human-generated data from AI-generated data. But this new generated data will be part of a new training set for a new model that will come, or they're already retraining or fine-tuning these models on generated data. So what will you expect to find, or what will you find in 10 years? You don't know. You might find data that is not usable to train because it's going to be so artificial, or it will not add. You can even reach so-called a data plateau, for which you are not adding new information to these models, and they're not learning anything else than what they already know. So we have to consider all these, consequences of having these models in action on a daily basis on the internet and operating in a semi-autonomous fashion. Now, what is happening from the investment and investors' point of view? I've seen several trends or waves, if I can call it like that. Of course, the first ones has been all about hype and new trends and hype. Let's call it with the real name. So there have been the Elon Musk and the Sam Altman of the world, actually Sam Altman himself, telling that this is a magical thing, and that people have to invest in this thing because it's the next big thing that humanity will ever face in the history of humanity, right? Not exactly these words, but this was the message. I mean, we have to be honest, and that didn't happen. So there has been this initial hype in which all investors have been, following and putting their money at. Many of these already have given themselves rewards by moving somewhere else. There has been a slowdown looking at some of the trends in investment in generative AI, and it's very easy to find this data. Even Crunchbase, there is this weekly report on the number of $1 million invested in some families of companies or startups. And you can see, if you have enough patience and start collecting these numbers and putting on a graph, you would see very interesting trends. I will hopefully can share some of these very nice pictures on the official website of datascienceathome.com. I usually add this information to the show notes of the episode, and of course I will do so for this episode as well. That's the second wave of investment. It has been a kind of a slowdown, which is normal in all brand new technologies, it's quite okay. Um, and now there is some kind of acknowledgement, general acknowledgement or global acknowledgement about the fact that maybe AI is not really keeping the promise, or well, we don't see an immediate future for which AI or generative AI can keep that promise, which was initially very, very ambitious. And so now there are investors rewarding only the companies that can actually tie spending to revenue when it comes to generative AI. So only those, and I have to say, very few companies that can generate revenue with generative AI tools. These are very few. It's definitely not the global trend. There are many, many startups that actually rely on OpenAI and other providers when it comes to generative AI or GPT family of models, and they built a business on top. I honestly don't care how critical their business is and how dangerous actually it is to rely on a supplier that is actually, is the core component of your business. That's a very fishy strategy, in my opinion, to say the least. But revenue, like, are you actually generating revenue with that model or with that particular feature? Very few can say that. And the numbers are talking. Now, who are the winners? Well, the investors who already, gave themselves rewards and moved their capital somewhere else to, less ambitious, not less ambitious, but more realistic, because it's kind of a balance. We have to find a nice line between less ambitious and realistic projects. But the investors who came out of the first wave, in my opinion, are the winners. Another family of winners is definitely chip manufacturers. GPUs are definitely the basic ingredient of generative AI technology, and it will stay so for the years to come. So NVIDIA, of course, is dominant there. It's very hard to dethrone NVIDIA from that podium. Because it's a great company and they do great stuff. They do the best chips, the best GPU chips in the world, and that's undeniable. And I'm very sure they're gonna continue doing so. It's very hard to tackle that market for many other players out there. There might be maybe the usual big scalers like Microsoft and Meta and Amazon probably, who can, let's say, expand in the GPU market, but or in the chip market, but I'm not 100% sure they're gonna, even tickle the belly of NVIDIA at this point in time. I think that the next big winner here is energy companies, and that's my biggest speculation in this show is just this one. Power supply will drive this type of artificial intelligence. It is already doing so, and it will do so for the next years at least. Due to the fact that it's very hard to believe that overnight we're going to have a generative AI model that performs as good as the models we are already used to, and at the same time, with a fraction of the energy or the power consumed. It's very hard to believe that. There is a lot of room for improvement, of course. We have seen also many episodes on this show, Data Science at Home, talking about quantization, talking about model compression, and many other techniques. But we're not there. And of course, as I said, don't forget the fact that in 5-10 years, you want to see these models improving not only in the efficiency, energy efficiency, but also in the capabilities that they provide. You would never accept a model, a GPT 2023 that does exactly the same things in 2030. You will not accept that. So consider the fact that the longer we go in the future, the more capabilities and the more complexity we expect these models to handle. So think about that. So again, to conclude, big winners. The hype stars actually is another wave of which are kind of the investors who already came out of that hype. Um, and the hype stars are still making money, in my opinion. They're still the winners of this new trend, probably until the next AI winter, which in my opinion is gonna happen. It's the the normal cycle of things. Let's see when it will happen. It's a matter of when. It's not a matter of if. Um, so yeah, and then of course utilities. So don't take my observations as an advice for investment, but I think that energy companies will definitely surf the wave of generative AI and AI technology in general. There's no power. There is power improvement, but not enough to, let's say, threaten the market uh, of utility companies and energy companies, as I can see now. So well, this is partially my personal opinions, and of course partially a summary of what I read by this very interesting report, Goldman Sachs Gen AI report 2024. Very, very interesting. I will provide, of course, the PDF or the link in the show notes of this episode at datascience@home.com. And of course, I hope you enjoyed the show and speak with you next time.